Hello there, welcome to the June 2019 paper 1. Here we're looking at question 3. Figure 1 shows that the design for a tabletop in the shape of a rectangle ABCD. The length of the table AB is 1.2 meters. The area inside the closed curve is made of glass and the surrounding area, figure 1, is made of wood. The perimeter of the glass is modelled by the curve with polar equation r equals 0.4 plus a cos 2 theta, where theta is in between 0 to 2 pi. Show that a is equal to 0.2. Okay, well, I imagine the centre of this diagram here is in the middle, so from here to here, that's going to be 0.6, and this line here is also what's referred to as the initial line, or when theta is equal to 0. So what I'm going to do is plug in theta equals 0 into my equation. When theta equals 0, r equals 0.4 plus a times cos of 0. We all know cos of 0 is 1. Now we know that the radius at this point is 0.6. So I'm going to substitute the radius for 0.6 equals 0.4 plus a. Take the 0.4 onto the other side and you get a is 0.2. So there we are. So it's also confirmed to us that the centre is in the middle. Right, now that we know that a is equal to 0.2, let's just write that in there, 0.2. Hence, given that the value a to d is 60 centimetres, I'll put it on this side, 60 centimetres, find the area of the wooden part of the tabletop, giving your answer in metres squared to 3 significant figures. Well, the area of the rectangle here, the rectangle is going to be 1.2 times 0.6, which is equal to, let's grab a calculator, 1.2 times 0.6 is 18 over 25, or 0.72 meters squared. Okay, so now we know that, so let's just take away the area bounded by this curve then. I think the way I'm going to do this is I'm going to split this up into 4 separate parts. I'm going to split it up in between an integral from 0 to pi by 2, and then just multiply that integral by 4 for the 4 different sections. So remember that the integral for a polar area is a half integral r squared d theta. Now, because I've got 4 areas, my total area is going to equal 2, because it's 4 times this half area, 2 times the integral from pi by 2 down to 0 of r squared. So it's going to be 0.4 plus 0.2 times cos 2 theta squared d theta. Okay, so let's now expand these brackets. It's going to be integral from pi by 2 down to 0 of 0.4 squared. 0.4 squared is 0.16. The next bit is going to be 0.4 expanded with a 0.2 twice. So that would be 0.16 again, 0.16 cos 2 theta. And then the next bit is going to be 0.04 cos 2 theta squared d theta. Now the next thing I think I'll do, just to simplify all the values here, is take out the hundredth. So it's going to be 0.02 times the integral of pi by 100. So pi by 2 down to 0 of 16 plus 16 cos 2 theta plus 4 cos squared 2 theta. In fact, at this point here, I could factorise out 4 as well, couldn't I? So if I factorise out 4, I'm going to get 0.08 times the integral from pi by 2 down to 0 of, if I factorise that 4, it's going to be 4 plus 4 cos 2 theta plus cos squared 2 theta. Okay, so that's simplifying the coefficients here, but now the important bit here is to work out how I'm going to integrate this cos squared thing here. Now, just a reminder that we have a double angle formula for cos, which is cos 2, which is cos, let's do that again, cos 2x equals 2 cos squared x minus 1. But where we have our cos squared, we actually have 2 theta. So we actually need to replace x with 2 theta. So when it says 2 times x, it's now going to actually be cos 4 theta equals 2 cos squared 2 theta minus 1. So now when we rearrange this, it's going to be a half cos 4 theta plus a half equals cos squared 2 theta. So it's got 4 angle theta in there, which is fine. We can deal with that. So it's going to be 0. In fact, what I'll do is I'll bring back in a factor of 2 into my brackets so that I can then get rid of those halves straight away. So I'm going to bring a factor of 2 back in. So it's going to be 8 plus 8 cos 2 theta plus 2 lots of this expression here, so that will make it now just cos 4 theta, and then plus 1, so actually I'll change this 8 to a 9 at the front here, d theta. Okay, now we can start integrating, so it's going to be 0.04, and now integrate 9, that will be 9 theta, plus cos integrates to sine, so it's going to be 4 sine 2 theta, and then it's going to be plus a quarter sine 4 theta between pi by 2 down to 0. Okay, so let's now expand what we've got here. It's 0.04 multiplied by 9 pi by 2. And then when you put pi by 2 into sine of 2 theta, that will give you sine of theta, which is 0. Sine of 2 times 2 pi is 0 as well. Substituting in 0 here, you get another 0, 0, and 0. So the majority of this stuff here is just 0. So then we'll do 0.04 times 9 over 2, which will give us 9 over 50 pi. 9 pi over 50. So, therefore, the total area now, the area on the wooden bit, is going to now be 0.72 take away 9 pi by 50. So, let's do this calculation then. My previous answer was 9 over 50, so times that by pi. Answer times pi. And then we'll do 0.72 minus answer, and that gives us 0.155 to 3 significant figures. 0.155, and that will be meters squared. Whew, so there we are, that's the answer for question 3 there, worth 10 marks in total there. A lot of being careful on your integration there. Don't do too many steps in one in this question here, because you can get yourself muddled. Make sure you replace your cos squared with a double angle formulae, and we get 9 pi by 50. Subtraction will give us 0.155. So there we are, that's the answer for question 3, worth 10 marks in total there. Let's now move on to question 4.